Hello everyone, today we will discuss about moments. Let g of x be a real function of random variable x. So we have the random variable equal to x and g of x is the real function of random variable x such that let g of x equal to x raised to n where n equal to 0, 1, 2, 3 etc. Now the expected value of g of x is called the moment, that is expected value of g of x we will call it as moment about the origin of the random variable x. So it is represented as mn, where n is the order of moment. So m of n equal to expectation of x raised to n. So this will be equal to, for the case of continuous random variable, that can be written as integral minus infinity plus infinity x raised to n fx of x dx. And in the case of discrete random variable, this is for continuous random variable. In the case of discrete random variable, it can be written as sigma over all I xi raised to n p of xi. That is probability that the random variable x takes the value xi. Now what will be the zeroth moment? That is, what is m0? That is n equal to 0. m0 is integral minus infinity plus infinity. This is equation number 1. 1 gives minus infinity plus infinity x raised to 0 fx of x dx, right? So which implies x raised to 0 is 1. So integral minus infinity plus infinity fx of x dx, which is equal to 1. We know that the total area under PDF curve is 1. So we can say that zeroth moment of the random variable x is always 1. Now what about m1? m1 is integral minus infinity plus infinity x raised to 1 into fx of x dx. So we know that this is the mean value of the random variable. Now what about the second moment? m2 is integral minus infinity plus infinity x square into fx of x dx. What is this quantity? Second moment is, we will call it as mean square value. Mean square value of the random variable x. Now what is the physical significance of mean square value? So if you assume that the random variable x is a random signal, then mean square value is, or m2. m2 is the average power of this random signal x. Now square root of m2 we'll call it as RMS value. So these are the some physics. Now we will discuss about moment about mean. Again, let g of x be the real function of random variable x such that g of x equal to x minus mu the whole raised to n, where mu is the mean value of the random variable x. Now the expected value of g of x, we will call it as moment about mean. So this can be written as expected value of what is g of x. G of x is x minus mu the whole square, right? So this will be equal to integral minus infinity plus infinity x minus mu the whole raised to n into fx of x dx. This we will call it as nth central moment എന്ന് പറയും. Central moment. Nth central moment or nth moment about mean. In the case of a discrete random variable, I will write it as sigma or all I xi minus mu the whole raised to n into p of xi. Now what happens if in the case of n equal to 1, for n equal to 1 what happens? For n equal to 1, so we can write it as expectation of x minus mu the whole raised to 1. Right. So this is expectation of x minus expectation of mu. We know that expectation of average value is average value itself. Now expectation of x is mu. So this is mu minus mu itself. This will be equal to 0. The first central moment will be 0. Now what about n equal to 2? N equal to 2 is expectation of x minus mu square. So this will be equal to minus infinity plus infinity x minus mu the whole square into fx of x dx. So this we will call it as variance of the random variable. Variance of the random variable x. So we can say that variance is the second central moment. So in the case of discrete random variable, this can be written as sigma rho I x minus mu square into p of xi. So this is for variance of discrete random variable. This is variance of continuous random variable. Now variance can again be written as expectation of x minus mu the whole square, right? So this can be written as expectation of x square minus 2 mu x plus mu square. So this will be equal to expectation of x square minus, so this 2 and mu are constant, so it will be taken outside, 2 mu into expectation of x plus expectation of mu square. Expectation of mu square is also mu square. So this can be written as mu square itself. So this can be written as expectation of x square minus 2 mu into expectation of x is mu itself. So 2 mu square plus mu square. So this will be equal to expectation of x square minus mu square. So that means this can be written as mean square value minus square of mean value, which is equal to variance. So this variance can be written as mean square value minus square of mean value. Now we will find the variance of binomial random variable. So we know that by definition of variance, we will write it as expectation of x minus mu the whole square can be written as expectation of x square minus mu square, right? So we need to find the mean square value of binomial random variable. So we will write x square as x square equal to x into x minus 1 plus x. That is x square minus x plus x. So that will be equal to x square. So now expectation of x square can be written as sigma k equal to 0 to n k square into p of x equal to k. Right. So this can be written as sigma k equal to 0 to n k square into probability that x equal to k is n c k p raised to k q raised to n minus k. Right. So we know that k square can be written as k into k minus 1 plus k. Right. So this can be written as k equal to 0 to n. K square is k into k plus k into nck p raised to k q raised to n minus k. So this can be written as sigma k equal to 0 to n k into k minus 1 nck p raised to k q raised to n minus k plus k sigma k equal to 0 to n k into nck p raised to k q raised to n minus k. So this we already know, this is mean of binomial distribution. This is mean. So this can be written as sigma k equal to 0 to n k into k minus 1 into nck is n factorial by n minus k factorial into k factorial into p raised to k q raised to n minus k plus what is mean value of binomial distribution, that is np. Now this will be equal to sigma k equal to 0 to n k into k minus 1. N factorial can be written as n into n minus 1 into n minus 2 factorial p square into p raised to k minus 2 q raised to n minus k divided by k into k minus 1 into k minus 2 factorial into n minus k factorial. So k, this will cancel. So finally we have this can be written as n into n minus 1 into sigma k equal to, so what we left is n minus 2 factorial. So we need to start from k equal to 2 to n minus 2 factorial divided by k minus 2 factorial into n minus k factorial. So p square I took outside. We have p raised to k minus 2 q raised to n minus k. So this is again the expansion of binomial. But this is again binomial expansion. So this can be written as p square into n minus 1 into p plus q the whole raised to n minus 2. So this we know that this is 1. Now what left with is plus np, right? So this can be written as, so this is expectation of x square. Now what about variance? Variance of x is expectation of x square minus mu square, right? Square of mean value. So this will be equal to np square into n minus 1 plus np minus, what is mu square is n square p square. So this can be written as n square p square minus np square plus np minus n square p square. So this will cancel. Finally we will get it as np into 1 minus p. So this will be equal to npq. So variance of binomial random variable x is npq. Mean is np. So please find the variance of Poisson random variable as a homework. Thank you.